So, hello everyone, very good evening. Hello everyone, very good evening. Is my voice is clear? So, very good evening, Ankit, Vaishnavi, Huma Srinivasan. So, very good evening to all. Thank you for your presence in my third day of masterclass on advanced VLSI design and verification. So, good evening, Chaudhary. Good evening, Reddy. So, Vamsi, good evening. So, Siddharth, good evening. Thank you for joining. So Narayana Murthy, good evening. So very good evening. It's special to your joining your presence here. So okay, thank you for your response, Murthy. As my voice is clear. I think my face also visible for you. I think hope it's clear also. So Jayaprakash, very good evening. So Narayana Murthy, good evening. So Aish, very good evening. Muhammad Tawfiq, very good evening. Thank you for joining. Thank you for your presence. And then just a man with a T. Yeah, very good evening. Thank you for joining. So today we are gonna see at digital electronics. So this is a very basic need for VLSI engineer. So as you are a VLSI engineer, you must have the basic knowledge about digital electronics. So then only you can capable to understand the depth knowledge in VLSIs like a transistors, deep flip-flop, latches, and then Verilog code. So if you want to write the Verilog code also, you must know the basic digital electronic circuits. Okay. So very good evening. Thank you for joining. Uma Srinivasan, it's clear. Thank you for your response. So I have one interesting question today. So I will ask within 2 minutes. So let's wait for a few minutes. Remaining people have to join. So Siddharth, good evening. Yes, Siddharth, yes. So thank you for response. Varalakshmi, good evening. Better thoughts, good evening, sir. Thank you. So Radhakrishnan, hi bro. So Hogan Data, very good evening. Different name. So we'll start the session at sharp 7:05. So yesterday we seen computer architecture. So we have seen design flow and in first day like a chip design making, and then what is a front end back end, and then yesterday we seen computer architecture, how computer architecture control the hardware. So this is an interface between the hardware and the software. So there is an ISA instruction set architecture. Based on that only our CPUs are working. Based on that instructions only our CPUs will working. So thank you for your joining. So today we are going to digital electronics. So this is a basic knowledge of VLSI. So in this digital electronics, it's a lot of things like a number system, sequential circuits, combinational circuits, and then logic gates, and then Boolean algebra, and then K-map. So there are a lot of things in digital electronics. So better if you want to start your career as a VLSI in a VLSI field means you must thorough in with digital electronics. Starting from number system, binary, hexadecimal, conversion between decimal to hexadecimal, conversion of BCD to binary to decimal, and then coming to the digital electronics part means combinational circuits, sequential circuits. These are the basic skills you must learn, and then you have to practice a Verilog code for that also. So Tarun, Vasu, good evening. So let's see one by one in this session. Today we are gonna cover the basics, number system, and then logic gates, and then what are the universal gates, why we are calling that particular NAND and NOR gate as universal gates. So we'll see the example, we'll see the why we are calling that universal gates in this session, and also we will give the we will see the basic intro of combinational circuits. Tomorrow we will take the combinational and sequence circuit with the circuit, full adder, half adder, flip-flop, JK flip-flop, latches. There are a lot of contents in this tomorrow session. Today we are going to base of digital electronics. So I think we'll start today. So before going to start, I will ask one question. So can anyone guess what is the name of this transistor? So it's visible for you. So please respond in chat box. If you know this name of this particular transistor, you can respond in chat box. What is the name of this transistor? So why? Because of why I am telling this means, so in depth we are controlling the transistor. So we are using computer, we are using mouse, keyboard, we are giving some instruction to CPU control the hardware, and the ISA control the hardware. It is we know that, but how that ISA will control the hardware? So this is based on the the main hardware is BJT. So BJT means you are telling correctly, BJT, bipolar junction transistor. So if you want to if you want to know the working of transistor, means you will start from BJT. So how it works? So can anyone response in chat box? Bipolar junction transistor is correct. And then so how it is work? So there are three terminals is there: collector, emitter, base. Here we are giving the base current. So this is a current control. So this is a current control device. Okay. So emitter, there is a symbol missing, emitter, but here in the collector side we are giving some supply VCC, where we are giving some input current, and then here we can, this is a base, this is a insulator, semiconductor, this is insulator, it will act as a semiconductor, and then emitter, in the emitter side we will get the output. Okay, by giving the base in the base side we are giving the input for this transistor. Based on that input only it will switch on or off. It means it will give 0 or high based on our current input in the base side. Okay, I think you are you are familiar with this transistor. 8 arrows is the 2 nodes NPN transistor. Okay, correctly. So Narayana Murthy, you were telling correctly. So I will ask this question. This is my question. So this is the working of transistor. So if there is a supply in the current supply in the collector, if you given some input threshold current for this insulator, then only it will conduct. You will get then only it will switch on the transistor. Then only you can get the output. Then only you can get the conduction output. Like if you are given like a 5 volt, means you will get the 5 volt here in the emitter based on the base current supply. Okay, this is a control. This is basically BJT is a current control device. By giving the base current we can control the device. Either if it is based on the silicon, what silicon you are using. If it is a 0.7 like a silicon means silicon is one semiconductor device. The threshold voltage of that is 0.7. okay, germanium 0.4, I think so. So based on this based on the threshold voltage, the threshold current, we can control the transistor. We can switch on, we can switch off that based on the input of base. Okay, so my question is, what if I connect the true transistor? It can be BJT, it can be MOSFET, it can be MOS transistor, it can be BJT transistor. What if I am connecting the two transistor as a serial? What you will get as a result? Can anyone respond in chat box? What I will get the output here if I am giving? So this is an input supply. If I am controlling this two transistor by the base input I am giving the 0 volt, 0 current, 0 current for these two transistor. So what will my output here? Either 0 or 1. Can anyone respond in chat box? And so Naga Srinivasaru. So and is a correct answer. It will do the AND operation. Why? Because of if both input are, so there's a pass transistor. If the both input are high, means you will get the output here 1. Otherwise you will get as 0 only. Why? Because of here here I am giving 0, so it won't on. It is in the off condition. If here I am giving 1 here, this transistor I am giving 1 here, so it will conduct. But if for the transistor it didn't receive input supply, so it will transmit only 0, so it will give output as a 0 only. So if you are giving the both input for these two transistor as a 1, here 1, here 1, you will get the 1. Otherwise if either this transistor or this transistor either 0 or 1, means you will get the 0 as output. Basically this is a functionalities of AND gate. Okay, so this is a logic behind the AND gate. So this is a process how transistor works based on belongs to, like it's behind the ALU. So we already yesterday we seen like a arithmetic logic unit. So it will do addition, multiplication, division, lot of things. It will, just a minute. So yeah, is my voice is clear now? Can anyone respond in chat box? Clear and louder. Can anyone respond in chat box? Priya, same input became output. Yeah, correct. So no, same input means if you are giving the 0 0 means you will get a 0 only. If you are giving the 1 1 means you will get the output as 1. If you are giving the different 0 or 1 for these two transistor, you will get the output as 0 only. Okay. Yeah, thank you for your response. So this is how our ALU, arithmetic logic unit, will work. If you connect the two transistor as a serial, you can get the AND operation. Okay. So and then this is how look like this. If you are giving like a 1 1 here, it means it will pass. It will this transistor will receive the input supply from here, and then it will given to, so it will give the output in emitter side, and then it will input for this collector. So we can make the circuit, we can make the current passing along these two transistors. So we can on these two transistors by giving inputs of base 1 1 1, then only you will get the 1, otherwise you will get a 0. So and then my another question is what if I, so this is an example for AND gate or already said no. So we can make the truth table based on this circuit. Okay. So I here AND gate having two transistors, it having the two input x and y. If both inputs are 0 0 means you will get the 0 as output. If both inputs are 1 1 means you will get the 1 as output. Otherwise, if either inputs of x and y 0 or 1 means we will get as a 0 as output. Okay. So and then I have another question. Both logic 1, then output is 1, they will turn on gives output. Yeah, correct. So Habibullah. So Habibullah, you are telling correctly. So your response is correct answer. That is exactly what I am conveying to you. So and then I will ask another question. What if I connect these two transistors as parallel? Okay, you can see here if these two transistors as a parallel, what it will do? It may be either a BJT, or it may be other MOSFET, MOS transistors. So Priya 1. So what is 1? So what you will get as your output? So if I am giving like a here x equals 0 and y equals 0, what is my output here? So can anyone respond in chat box? My assume like a scenario like a x equal to 0, y equal to 1. So what is my output? So what is basically what functionalities this circuit will do? If I connect this these two transistors parallel, what will be the output? What is the functionalities of circuit? Yeah, correctly. So you are telling correctly logic OR, so it will perform the OR operations. So if you connect two transistors parallel, you will get the AND operation. If you connect the two transistors as a series, if you connect the two transistors as a parallel, you will get the OR operation. Okay, OR operation means if either our input is 1 means you will get a 1 as output. For example, here it is 0, it is 1. So it will conduct, this transistor will on, so 1 will be output here. So 1 will comes over here, you will get the output as 1. Okay, same like this also. If it is 1, is 0 means you will get as a 1 as output. If both inputs are 0 only, if x equals 0 and y equals 0 only, you will get the output as 0. So this is how basic transistor are helping to do arithmetic logic operations. Not only for these arithmetic logic operations. So basically yesterday we seen ISA. So what we are doing, so in this register memory we are storing instructions and datas. Okay, so instruction means it may be a arithmetic logic unit. So we are in the instruction we are telling addition, you have to do addition, you have to do multiplication in the instruction. So by in the depth ALU arithmetic logic unit will do this only. So it will make it will have some circuit and operation or operation. Based on that it will give the output. Okay, based on the instruction it will give output. So by default, by in depth, we are controlling the transistor by using the ISA. So in this ISA it having lot of registers. ISA is nothing but each and every computer architecture having ISAs. For example, if you take in RISC-V, it is also having ISA. And then ARM architecture, in ARM architecture also it having lot of types of ARM architecture. M series, in M series it having the 4 types of ARM architectures. and then x86 by Intel. So x86 is also an architecture is given by the Intel. So copyrights are having by the Intel. So these are basic things. So every architecture having the ISA, based on the ISA we can ISA we can do the instructions. So that mainly the arithmetic logic unit will do the main operation of your instruction. So arithmetic logic unit is look like this only. So transistor, by based on this transistor we will make some circuit. It will do AND operation, it will do OR operation, it will do XOR operation, and then it will do AND full adder, triple carry adder, decrement, increment. So based on that instruction it will make some circuit. Okay, so this is how basic flow of computer architecture and system working, computer workings. So this is how transistor will help to arithmetic logic unit. So it's clear now. It's till now, do you guys any doubt? So better thoughts. Yeah, thank you for response 110. So thank you for your response, Demon King Radhakrishna. So thank you for your response, your valuable response. So this is the basic thing I want to share today. So and also we'll see the digital electronics. Before that, I will share some interesting thing about internship. So if you guys are really interested in this 30-day masterclass, you can convert into 1 month internship on advanced VLSI design and verification. So these are the benefits you will get at the internship, from the internship. Like you will get the 30 days recording sessions. You can also download the PPTs, downloadable source code, and then all other resources you can downloadable, and then you will get the projects, 4+ projects. It may be having the mini project and major projects. In this master class we are providing, in this internship we are providing major projects like AMBA protocols. It is very useful for SOC verifications. If you are interested in SystemVerilog, by using SystemVerilog we are going to make project in SOC bus protocols. Okay, so and then you will get the IETE confirmation letter, and then you will get the 180 days of LMS course access, and we are providing weekly live sessions, and then we are providing assignment and tasks, and also we are providing academic internship report. It is very useful for if you are studying in college students. It will very useful to you. And then you will get the high valued IETE certificate, IETE internship certificate. So this is a central government kind of institution. Okay, so this is if you want to really buy this internship pins, by using this registration link you can get. This is the registration link, and also our organizer will post the link in chat box. You can use that to buy this internship program. So our regular fee is 4,999, but in this masterclass period we are providing discounted fee of just 999. So if you guys are really interested, you can avail it. So this is a limited time period offer. So and then you will get the certificate like this. So before that, in the registration link you will see this UI. It will look like this only. Here you can fill the details, your basic details, name, email, WhatsApp number, department, institution name. In the domain section you have to choose advanced VLSI design and verification. Then only you will get that internship, or else you will get another internship called AI Python. We are providing a lot of internship. So if you want this, means you have to choose advanced VLSI design and verification separately. Okay, so this is a method to get the internship, and also you will get the internship certificate at the end of the 1 month. Look like this only. It's a sample certificate. So if you guys are really interested, you can get this internship program by using this registration link. Okay, so thank you. We'll see the digital electronics basics today. So today we are gonna see the game map, and then logic gates, and then number systems. So basically digital electronics is nothing but we can make the circuit, but it will work based on the zeros and ones only. So digital means what? Zeros and ones. So analog circuits, it will perform the continuous kind of things, but here we are using, in digital electronics we mostly works with zeros and ones. So that's called is a digital zeros and ones. So digital electronics involves circuits that operate using digital signals. Okay, so fundamental concepts include like a K-map, number system, Boolean algebra, combination circuits, sequence circuits. We'll see in upcoming slides. So this is a basic overview of digital electronics. Okay, so ISA full form, Priya. Well, so instruction set architecture. So instruction set architecture is the full form for ISA. So if you want to recall means, so ISA comes under the computer architectures. There are computer architectures nothing but, so the CPU want to perform, CPU won't perform without any rules and regulations. So we have to give some architecture like a building. So for example, if you guys know the Iron Man, so all people are maybe aware of Iron Man. So they are having some suit like Iron Man suit, like a fully filled with metal bodies. So that is architecture. So we are the humans. CCP is a woman. CPU is human. Like imagine like a Iron Man hero is a human. It's a CPU. So by using the that CPU having some architecture. So based on the Iron Man using that suit, iron suit, to control, to fly, to hit the enemies by using that they are that human, that Superman using sorry, the Iron Man using the Iron Man suit to control, to destroy the peoples. So same like that, CPU having some architectural. So CPU have to follow that rules and regulation and the architectural rules and then flow of architectural, then only that instruction will execute perfectly. So we will get the perfect answer, we will get the perfect result from the CPU. Without this architecture we can't get the perfect results. So there are a lot of architecture in the market, risk and architecture, x86 already said no. Each and every architecture having the ISA instruction set architectural. So based on that only we can control the hardware, we can perform the arithmetic logic unit, we will get the result from the CPU. Okay, I think it's clear for you, Priya. So and then let's move into concepts of digital electronics. So here we will see the number system. So number system is a basic things. So we are having a lot of number system like a binary number system, like a hexadecimal number system, decimal number system, and then octal number system. So a number system is a way of represent the numbers using consistent set of symbols. So if you want to represent the binary digit means, you have to follow the base 8. So base 8 is refers to, it may be either 0 or 1. So there are 2 bits only. Okay, so and then decimal system means you have to follow the base 10 representations. It start from 0 up to 9. So 0 to 9 is a decimal number system. Octal means 0 to 7, and then hexadecimal means a 16 bit base 16 bit. So it start from 0, it will end from 15. 0 to, so 0 to 9 is a decimal. After the 10 10 is A, and then 15 is F. So this is a hexadecimal number system representations. So there is some calculation, conversion of binary to decimal, decimal to binary is very it's like interview questions. It's also important for VLSI engineers, so you must learn about this. So this is very basic things you can learn from your own. So this is the number system in digital electronics. There are 4 types: decimal, binary, octal, hexadecimal. Binary means zeros and ones. Decimal means it will start from 0 and end from 9, and then octal means 0 to 7, and then hexadecimal is a 16, base 16. 16 means 0 to 15. Okay, so yeah, better thoughts were telling correctly. So and then we'll move to, so these are the basic things. I will move to the another topic. So this is look like all the number systems. Decimal 0 to 15. Here this is a representation of in the binary of 0 to 15. So here is this, here the representation of the octal of decimal 0 to 15. Okay, this is a representation of the hexadecimal of 0 to 15. So you can, this binary and hexadecimal is very easy for you, easy to understand. But you can see here octal. So in here it will start from 0, and then octal means base 8. So it will start from 0, it will up to 8 only. So 8 means 7 only, 7 is 0 to 7. Okay, 10 is represented as A. Yeah, correctly. So Chandru, you are telling correctly. So here in decimal we are having the 0 to 9. After that there is no if you want to declare the decimal, we can declare as a decimal as a decimal 10 as a 10. But if you want to declare as hexadecimal means you have to follow this. A means decimal 10, B means decimal 11. So you can easily understand this. So this is a basic structural like a basic number system. So please go through it, it's very simple only. So and then coming to the Boolean algebra. So this is a main important thing. So Boolean algebra. So we having a lot of circuits. So by using the AND gate we can make the circuits. Okay. Uh, we can make the circuit by using the AND gate logic gates, like it may be AND gate or gate. But if you want to reduce the circuit size, means you have to follow the Boolean algebra. So like a mathematical algebra like that, we having the digital Boolean algebra. So it looks like I will show you one by one. It having some rules and regulations. It having some rules. So I will show you one by one. So Boolean algebra is a mathematical foundation of digital circuits. Okay. So here if we are using some variables, literals and terms. For example, if you take this here, if you function y equal to a complement plus or operation and then a and b. So this is one Boolean expression. Function y equal to complement of a or a and b. It means it having the three literals. So literals means literal is nothing but variable. So there are two variables, a and b is a two variables, but complement of the variable is also called as literals. Okay. So here a complement is also is called as a literals. So a is one literals, and then complement of that particular variable is also called as literals. Okay. So totally it having the three literals, a and then b. And then there are two terms. So terms is nothing but operation. It may be and or operation, arithmetic operations. So here is a or operation, this is one term, and then this is an and operation, this is second term. So totally this Boolean expression having three literals, two variables, and then two terms. Okay, it's clear for you guys? So these are the basic needs of Boolean algebra. We must know what is the literals, what is the variables, what is the terms in Boolean algebra expression. So these are the rules of Boolean algebra. I think you people may study in school days and college days. So but it is very important, so you have to take in your mind. So this is a very needed basic rules of Boolean algebra. A plus a, if you do or operation of a or 0 is a or 1 is 1. Yeah, thank you, your response Narayan Murthy. And then a and 0 is 0, a and 1 is a. So and then a or a. So if you are doing or operation of a or a and a or a, you will get the a. This is a rule you have to follow. The why we have to follow these algebra rules means, Boolean algebra rules means, by using these rules we can reduce how to say, we can simplify the instruction, we can simplify the expression. So for example, I will show you upcoming slides. So you having some circuit, you are written in the Boolean expression, it will look like a complex circuit. If you want to simplify, means by using these rules, Boolean algebra rules, you can easily simplify. Okay. So literals means nothing but, so here, so I will show you this example. So here for example, assume like y is a function, so y equal to a complement or a and b. Okay, this is one equation, one expression. Here it having the two variables only, variables are a and b, but this a complement is complement of a, so I can assume like this is a literal. So this is one literal, this is b is one literal, and also a bar also one literal. So this is a literal. So complement of variable is also one literal. We can see in this example. So in this term literals, each occurrence of variable or its complement is called a literal. We can see now each occurrence of variable or its complement is called as literals. Okay, if there is occurrence of variable and also there is occurrence of complement of variable, it means there are two kinds of variables also called as literals. So each occurrence of variable and its complement is also called as literals. It's clear for your Pradeep Reddy. So literals means there are two variables in this expression a and b, but that a bar is also as we can call as a literals. This is one literal, this is one second literal, so we can also call this as a literal a bar. Okay, this is a thing we are explaining, I am explaining to for literals. So I think we'll get, so I will move to the Boolean algebra rules. So a dot a0, a dot 1 a, so a or a, and then a or a complement, you will get 1. So this is a main rule you have to take in your mind. We mostly use this rule to simplify the expression. So a dot a, we can assign like a, so and then a dot a bar 0, this is also important, we can use mostly, we are using mostly, yeah, in these three literals. So and then a double complement means you will get we can assign that a, and then a plus a b, you will this is a representation of a. So if you are having some expression look like this, we can simplify like a only. So I will tell you how we can simplify. These are simple only, so these are the basic rules we have to take in our mind, but this I have some methods I will show you upcoming slides. And then a or a bar b means I will simplify this expression. If I have some expression look like this, means I can simplify like this, a plus b. So and then a plus b, and then a r of and of a plus c, so we can simplify like a plus bc. So I will show you 10, 11, 12 expressions how we can simplify these expressions in upcoming slides. So if you taken like a 10th expression is nothing but a plus ab equal to a. So how we can simplify that expression to a? So you can see here a plus b, a plus ab. Okay, here a is a common, we can take it out, so remaining thing we will get as a 1 plus b. So 1 plus b is nothing but 1. So here here is AND operation, so a and 1, so a dot 1, so a dot 1 is a 1. You can see here a dot 1 is a dot 1 is a. So same like that you will get as a assign. So a as a simplified answer. So so Bharat Kumar, as if you want these classes, means you can purchase our internship program, you will get a lot of benefits from that internship program. So if you want to, means you can, by using the registration link, you can register yourself, so you will get the recorded sessions. Okay, and then I will move to the next rule. So it is clear for you. 10th rule, I will go to the 11th rule. So 11th rule is nothing but a plus a bar b equal to a plus b. So how we can do that? So a plus a bar b. So here, so already we know that a we can write as a plus ab. So I just write that a as a plus ab, and then so I can write also a equal to a dot a. So I can write this a as a dot a, and then I am multiplying this a bar b. So this a bar b inside this bracket, I will get this expression like this, a b, a bar a bar, and then a b bar. Okay, sorry, a bar b. After that, here I can take out my a outside, so like this. So you can see here is a and then a bar, and also I will take the a and a bar from this equation. So it's likely, it's after that it will look like this only, a plus a bar and then a plus ab. So sorry, a plus b. So a plus a bar, that you will get a plus a bar, you will get a 1. So I'm assigning to 1 here, a plus a bar I'm assigning to 1 here, and then I'm having the a plus b only. So and then 1 dot a means you will get a as a output. So 1 dot with anything means you will get the you can simplify as anything, so you will get anything as a output. So a plus b is a simplified answer. Okay, this is 11th rule expression. So and then I'm going to the 12th rule. So a plus b, the 12th rule is nothing but a plus b and a plus c equal to a plus bc. So this is a 12th rule. So we can get means, so this is a 12th rule. So I'm multiplying cross multiplication a into a into a into a, and then a into c, and then b into a and b into c. So this is a distributive law, so multiplying each and every variables. So and then already we know that seventh rule, a dot a equal to a. So I simplified this a, and then I taken a as out, I'm taking a outside, so a, and then 1 plus c. So it means I'm taking the a out, so it having remaining, it having a 1 plus c, and then here having same a b and b c, and then 1 plus c. So 1 plus c means what we can see that 1 here. So we can, by using the rule 2, 1 plus c, you will get the output as 1. So and then 1 dot 1. So and then 1 dot 1 means a. So 1 dot 1 means a. So I'm taking here a as a output. So I'm taking here from 1 dot 1 plus ab, I'm taking a as a, I'm taking a out, and then I will have I'm having 1 plus b. So and then if I solve this, I will get a 1 here, and then 1 dot a is a, and then remaining is b. So this is how simplifying the Boolean expression. If you understand this, means you can easily simplify the any expression. So just you have to understand, you have to take in your mind these basic rules. Okay, if you clear this rule, means you can simplify any Boolean expressions. So okay, and then coming to the gates. So I hope some many people are having aware of the gate workings. So let me know, so how many people are know the gates, what is the purpose of gates, how it works, so how many gate is there. So can anyone respond in chat box? If you know the working of gates, what is the purpose of gates, you can just put S in chat box. Then only I can proceed whether I'm explaining fully or I will move faster. Okay, so I will explain one by one. So first we'll start from AND gate. It will do multiplication operation. If both inputs are 1, means you'll get as a you will get 1 as output. We already seen by transistor example. Same like OR operation. It will do the addition operation. If both inputs are 1, it will get as 1. If either inputs are 1, means you will get as a output as 1. If the both inputs are 0 only, you will get a 0 as a output. And then NOR gate, so it is a complement of OR gate. Same like AND gate, it is a complement of NAND gate. So NAND and NOR are called as universal gates to perform Boolean functions. Yeah, correct, Narayana Murthy. And logic gate operations are done using gates. Yeah, operations are, yeah, correctly. Divya Sri, you are telling correctly, and then Narayana Murthy also you are telling correctly. And then exclusive NOR, so XOR gate. So XOR gate is nothing but if both inputs are same. If you having two inputs x and y, if both inputs are having 0 0 or 1 1, you will get output as a 0. If both inputs are different, means you will get as output as 0. So this is very basic input. So for example, if you are a student, if you are the college student or studying in final year preparing for interview, means the interview will ask some tricky questions based on the AND gates performance, like if gate functionalities. For example, so you having, for example, some kinds of question is in you having one room that but that particular room having two keys. If the both keys are if you have only two if you have two keys, then only you can open the room, otherwise you can't open the room. So they will ask what is the gate, so what is the functionalities of gate. So that door will work based on the some gate operations. So what is the gate, they will ask some these kind of tricky questions with they will compare with the real time examples, and then they will ask some questions. Okay, so AND gate is the correct answer for that question. If you are having one room, so if you have two keys, then only you can open the room, otherwise you can't open. So this is the functionalities of AND gate. If both inputs are high, means you will get the output as 1. Then so same like this, I'm asking that only. So I think it's clear for you. So XOR operation, so XOR is nothing but if both inputs are same, means you will get the output as 1. So XNOR is a exclusive NOR, so it means it is a complement of this XOR gate. So if both inputs are same, means you will get the output as 1. Okay, yeah, correctly. Kolachurthi, you are telling correctly. So and then this is a basic thing. So NAND and NOR called as universal gates. And also you must to know, you must aware of these symbols. NOT gate symbol, NOT gate is it's just doing complement operation. If you're giving, like if you're giving input 0 for NOT gate, we'll get output as 0. So before going to that, I want to know totally how many gates we are having. So what are the, so many how many gates we are having. So I want to just quick answer in chat box. So how many gates, totally how many gates in digital electronics? Can anyone response in chat box? Totally how many gates in digital electronics? How many gates? So can anyone respond in chat box? So totally how many gates we having? How many gates? 7. So what is if you guys know about aware of the buffer? So if here I am removing this bubble, what is this symbol? So what is this symbol? So if I remove this bubble from this NOT gate, and then what we can do, this is one gate also. Totally we are having the 8 gates, not a 7. What totally we are having the 8 gates. Buffer is also one gate. So if I remove this bubble here, it is act as a buffer. Okay, yes, buffer gate. So totally we are having the 8 gates, not 7. So universal gates are under, better thoughts were telling correctly, but main thing is we having the 8 gates. Buffer is also one gate. Okay, let's move into another topic. So universal gates. So why we are calling NAND and NOR as a universal gate? Can anyone respond in chat box why we are calling NAND and NOR as a universal gates? Buffer is what we give as input, it will be given as correctly. So Rishita telling correct answer correctly. So buffer will store what you are giving as input for buffer, you will get the same thing. Okay, so and then my question is why we are calling universal, so NAND and NOR is a universal gate. Why? Because of we can build all gates, like we can build NOT gate, AND gate, XOR gate, NAND gate by using the NAND and NOR gate. So that's why it's called universal gates. So universal gate is one with which all the basic gates can be built. So by using the NAND and NOR gate, we can build the all basic logic gates. Okay, so this is the example for this for the universal gate. By using the NAND gate, I can build NOT gate, I can build AND gate, I can build OR gate. Okay, whether I can also build XOR gate by using the NAND gate, and also I can build the NOR gate, XNOR gate. All other gates can be immediately NAND and OR gates. So okay, correctly. So Naranamurthy, you telling perfect answer, and then we can perform all logic operations by correctly. So Rishita, you telling correctly, and then I'm receiving correct answers. So better thoughts. Thank you for response. Chandru, we can make any logic. So correctly, Chandru, you are telling correctly. We can make any other gates. Okay, so thank you for response in chat box. You are telling correctly with exact answers. So this is a thing. So we can build any basic logic gate by using the NAND and NOR gate. So and then here you can also see by using the NOR gate I can build a NOT gate, OR gate, and then AND gate. Okay, and also XOR gate, XNOR gate by using the NOR gate. Okay, so thank you for your response in chat box. So and then I will move to the K-map. So K-map is also one very important things. This is a method to simplify the Boolean algebra expression. Okay, by using the Boolean algebra rules we can simplify somewhat, and then by using the K-map also we can simplify the Boolean algebraic expressions. So it is introduced by introduced in the year of 1953. It reduced the need for extensive calculation by taking advantage of human pattern recognition capability. So the basic need is we can reduce the we can simplify the expression by using the K-map. So I will tell you one by one. It having some methods, canonical forms like a sum of a product of sum. It is based on the min terms. So I will tell you one by one. So how we can build the K-map, how we can construct the K-map means we have to follow these steps. So determine the number of variables in expression, and then create a grid with the 2 power n cells where n is the number of variables, and then label the rows and columns with binary values, ensuring one bit changes between the adjacent cells. So 1 bit changes means it's nothing but gray code. So for example, in binary you having the 4-bit binaries. So 000 means 1, 0001 means 000 means 0. I'm telling the decimal values in binary representation. So in 0 we can represent in binary 0. 1 means 1, 2 means 10, 3 means 11. So if I change any one bit consecutive values, so I'm incrementing the binaries like a decimal value is 0, 1, 2, 3. There is an order like a 0, 1, 1, 0, 1, 1. If I change by 1 bit this order, if I change this order by 1 bit means that is a gray code order. So gray code means changing 1 bit for consecutive values. Okay. So and then fill the cells with output values from the truth table. So these are the basic steps you have to follow to make the K-maps. So it having two forms, canonical for it having two forms, sum of the product of the sums. Okay. So this is a canonical form of sum of the products. Okay, sum of the products. This is a product and sums. Okay. So it is a one expression function of a. There are three variables a, b, c. This is expression. I want to simplify this expression to like this. So how we can simplify means by using the Boolean rules and also by using the K-map we can simplify. Okay, they perform number of operations correctly. So by using this K-map we can convert this expression into this expression, simplified expression. Either you can use Boolean algebra rules or else you can use K-map. Okay, so this is the two variable min terms. 0 means SOP is fully based on the sum of the product, SOP. Okay, in sum of the product is a 0 as a min terms. So this is one min term, M0 is one min term, and then 0 1. So A bar B is a M1, this is one min term, and then 1 0 is my second min term, and then 1 1 is my third min term. So if you for making the K-map for two variables, like a two variable means we have to follow two cross like a matrix of like a two cross 2 grid, like a 2 cross 2 matrix. So but you have to follow this rule. What rule means? Label the rows and columns with binaries, ensuring one bit changes between the adjacent cells. Okay, so for that you have to follow this rule. So if you follow this rule means you can assume like this is for 0th min term, first min term, second min term, third min term. If you having the 2 cross 3 or 4 cross 4 grid means I will show you upcoming slide. There will difference between the 1 bit difference in the adjacent grids. Okay, so for example here I will show you this. So this is a 3 variable K-map. So here we can see 0 1, but I can give the 2 here. I can give 2 here in the third cell, but I can't give. So I have to follow the K-map rules. The main rule is label the rows and columns with binary values, ensuring only one bit changes between the adjacent cells. So if I 1 bit changes 0 1, and then if I give here 2 means there is no changes between adjacent. So I have to give 2 here in the fourth cell, and then 3 here, then 4 5 6 here, 7. So this is a basic rule. So we have to follow the rules of K-map. So we have to follow the gray code method to making the min terms in the 3 variable K-map, and then 4 variable K-map, and then 5 variable, 6 variable. So we have to follow the gray code method. The gray code method is nothing but changing 1 bit. Okay, so this is an example for 3 variable K-map. So and then this is a basic this is a one expression, Boolean expression. So I am simplifying this big expression as like this, a and ab plus cd. So this is my Boolean expression. I'm just simplifying this big expression like this only. So how we can do means, I am having the four variables a b c d. So there are four variables, so I have to make the k map a grid, like a 4x4 matrix. Okay, totally 16 cells is there. So here having the 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So there are 15 16, totally 16. Okay, so there are totally 16 cells. Okay, so and then values. So second rule is, what is the second rule? Label the rows and columns. So I'm labeling rows. I having the four variables. So these rows, this row I say I'm labeling as a cd. This row I'm labeling as a ab. Okay, this row like at this. This means here this is a input. This is a values for cd for this column, and then for this column for these are the inputs 0 0 0 1 1 1 1 0 for this cd column. And then row, if you take in a row means ab, so this is a value for this row ab. So 0 1, this is for this 0 1 value for the ab row, first row, second row, third row, fourth row. So my if I plot this expression into my k map. Plotting means I'm assigning the minterms here. So a bar a, so this means a 0, it means I can represent this as a bar b bar. So and then cd, so cd means c having 1, d having 1. So bar means 0, I think if you without bar means it is a 1. So 0 0 1 1 0 0 1 1, a having 0, b having 0, c having 1, d having 1. So 0 0 1 1, so I can plot 1 here. This is my first minterm. Okay, so I'm converting this and every this each and every expression into minterms. I'm plotting one, I'm putting 1 in my k map, and then I'm mapping. Okay, so there are rules in while mapping the k map. You can do two cells as one map, two cells as one, like one group, and also it may be vertical, it may be horizontal. So you can see here I'm mapping these four cells as one group, okay, vertically, and also I'm mapping these four cells, it's look like a horizontal. So I can group like I can group as a one group. Okay, so this is a one group, this is one group. So I can do also like this, like these four cells also I can make one group, and then I can make this first two rows also I can make one group, and then I can also map like this four corners of k map also I can make one group. So there are a lot of methods to make groups in k map. So 0 indicate and 0 indicates bar, 1 indicates not having bar. Okay, correctly. So in the SOF sum of the product, 0 means bar. If it is not having 0 means we can represent it as a without bar. Okay, so this is a if you plotting this expression in the k map, it will look like this only. So I'm mapping these two groups. So you can see here if you taken like a this row like a ab, if you taken like ab, so here continuously changing like a, for example, if I'm taking here, so if I'm taking this row one group, I want to make a expression from this group. Okay, so a b are same, they are in static, so I can give as a, I can simplify it as a ab, but we can't do directly, and we have to see the cd also. So cd will changes each and every columns. Okay, you can see here cd having 0 0 0 1 1 1 1 0. So there is no same thing, so we can't simplify this. So there is only same thing is ab. Okay, ABC only same thing we have in the group. So here it is changing, so there is no same thing. Like a same thing means if it is having 0 0 0 0 means, so there is no static messages, there are continuously changing, so we can't give as a output. So we have to write this AB. And also if you take this means here AB is continuously changing 0 1 0 0 0 1 1 1 1 0. So you can't write as a output. So you can write as a output CD. Why? Because of CD is in the static manner, so you have to write the CD only. Okay, so same like this, if you so I can map like this also. So I can map the four corners of the K map. So you can see here, if you take like a 0 0 1, so if you take this 0 0 and then 1 0, so there is a same, like a B A will change, like it will change from 0 to 1. So we can't write as a output. If you having the, you can see here B having the same thing. If you compare these two values 0 0 and then 1 1, why? Because of I'm grouping like this only, 0 0 1 1. So there is a transition between the 0 and 1, but there is no transition between between this 0 and this 0. So I can write as a B bar as a output. And also if you seen like this, if you seen like this row, there is a transition between there is no transition between C, okay, sorry, D. So D having the 0, and also here also D having the 0, but here C having a 0, here it is having 1. So there is a transition in the C, not in D. So we can write the output as D bar. Okay, so this is how we can map the K map. So I will show you another example. So if you plot these minterms in the K map, you will get this K map. You can group like this. You can, if you fold the paper means you can group the eight cells like this. So if you take these two rows, so there is a transition between the A 0 to 1, but not transition in 0 in the B. It stay in the same value of 0. So 0 here, 0 here, so I can write the 0 bar. But if you take this row like a CD values, it continuously changing. So 0 0 0 1 1 1 1 0. So we can't we can't write the output in the transition of CD. So there is if you simplified this expression in K map means, you will get as output B bar only. Why? Because of the B bar only is the same thing. Okay, so adjacent variables are removed, 2 adjacent variables and 4 adjacent variables are removed or vanished, remaining variables will be there. So yeah, correctly Srinivasa Saru, you're telling correctly. So this is a basic functionalities of K mapping. By using the K mapping, you can simplify the expressions. By grouping these K map minterms, we can simplify it. We can write some simplified variables, simplified expressions. So this is a basic use of K map. So and then this is for K map. So and then let's move into combinational logic. Okay, the combinational logic is nothing but based on the current input only it will work, it will give the output. Okay, this is a basic thing of combinational logic. So before going to that, I will ask one question. So how sound system works? So I think some of you guys know about the home theater. So we are having the home theater in our home. So home theater is having speakers like front side, right and left, and then back side also it having speakers like a back, right and left, and then subwoofer. And then there are 5. If you take an example 5.1 home theater, okay, it having the 5 speakers, one from right, one from front right, front left, back right, back left, and then one from center, and then we having the subwoofer. So we are know the sound system. So how it works? So what logic based on this? So there is one combination logic behind the sound system. So I want to know the what logic the sound system are working. Amplifier. So amplifier is it just increasing sound and some amplitude. It's just doing some amplification, but that division. So like we having the 5 speaker, but input is only one line. Inside that one line, we are dividing some inputs. Okay, sorry, we are dividing some output from one line, from for front speaker, for front right, for front left, for front back right, back left, for center. So we are dividing some output from one line. So what is the function? So there is a one combinational function begin that this scenario. So I want to know what is a basic combinational logic to use it for sound system, like a home theater kind of thing. Can anyone respond in chat box? So what is the basic logic of sound system? So you can guess anything. So I want to know just answer. So basically I am dividing. So I have one input, I am dividing into many outputs. So what is the function? Multiplexer or demultiplexer? Yeah, correctly. So you're telling, Narayanamurthy telling correctly, multiplexer, demultiplexer, and then decoder. So mostly decoder. Okay, decoder is the perfect answer for this question. Sound system. So sound system works based on the decoder logic only. So because of there is only one input from TV for home theater, so it will decode the sounds, right, front right sound, front right speaker sound, front right left speaker sound, and then front right like a front center sound, speaker sound. So we are having the 5 speakers. So that particular home theater dividing the separating or decoding the inputs from one wire. Okay, so they are just doing the decode operation. So this is a basic thing I'm just conveying to you. So combinational logics, combinational and sequential logic is very important. We are using everywhere. So for if you taking like a multiplexer means in telecommunication we are mostly using multiplexing. So and then yesterday also we seen like a binary decoder. Okay, yesterday we also am showing some 8-bit I think 8-bit adder. It can do 8-bit adder subtractor. To choose the what functionality means we can use the decoder. By using the decode function we can control the which functionalities you have to do. So this is just think about combination logic. So that this is for today. I hope this session will helpful for you, and then you will get some basic knowledge about combination logic. That is nothing. Combination logic is work based on current inputs. Okay, it will give the output based on the current input. But in sequential logic there is not like combinational logic. We will see the sequential logic tomorrow, and then we will see the combinational sum circuits today. That's for today. So tomorrow we will see the combinational circuits, half adder, full adder, triple carry adder, and then encoder, periodic encoder, mux, demux, and also we will see the sequential circuits like a flip-flop, latches, like a flip-flop, D flip-flop kind of things. So thank you for your presence. So this is if you guys are in doubt you can ask now. You can ask in chat box from this session if you guys have any doubt. Yeah, thank you for Siddharth, thank you for response. And also if you guys are really interested in this master class, you can convert into 1 month internship on advanced level citizen and verification. So you will get the benefits like this. These are the benefits you will get. 30 days recording sessions, you will get the 180 days LMS access. LMS means there is one portal, LMS portal, and on that portal we are stored the recorded videos you can watch at any time. And also you will get the weekly assignments, task, and then you can ask doubt in the weekly sessions. And also you will get the IETE internship certificate. So it is a central government institute, it's a valued certificate. If you are studying a college students, it's very useful for you. And then you will get the all 30 days recording sessions, and also exclusive projects, and then sources from PPTs, source codes, and then other sources like books, and then reference manuals you will get, and you can also download that. So this is benefits you will get at the end of the internship. It's just 999. Our regular fee is 4,999. In this masterclass period we are providing this internship as just 999. By using this link you will get, and also you will get the link in chat box, and you will get the certificate like this only. This is sample certificate. So okay, this is for today. We'll see the sequential logic and then combinational logic tomorrow. So thank you guys, thank you for listening. So I hope this session was helpful for you. So yeah, no problems tomorrow, no class. So So tomorrow means Monday. So sorry for the inconvenience. We will see Monday. So there is no class in Sundays. So I will take from Monday to Saturday. So Monday is the class. So thank you guys. Thank you for listening. We'll see tomorrow.